three charges each equal to Q are placed at three corners of a square of side A. Find the electric field at the fourth corner. Okay, so let me draw a square here. Okay, so this is our square, let's say. Okay, let's assume this is our square, and three charges are there, each of magnitude Q. Okay, are placed at the three corners of square side A. Each side is A. We have to find electric field at which one? Fourth corner. Correct. So let's find electric field at the fourth corner. So electric field at, let's name it electric field. This is our A, B, C, D. We have to find electric field at D. Correct. So what will be our field due to the first charge? Okay, at D point, radially outward, right? This is EA. Electric field due to the charge at C, it will be radially outward because positive charge, EC. Electric field due to B along the line joining and in this direction. I hope this is clear. Okay, great. Let's find the magnitude. Okay, so magnitude of EA, that will be KQ upon separation is A square. I hope this is clear. Separation AD is A. So KQ by R square. R is A here. Electric field due to charge C, that will be also KQ upon A square, right? Where A is what? The separation between CD. Correct. But be very careful here. B and D. What's the separation between B and D? Root 2A. How do you know that? If this is A and this is A, then using Pythagoras theorem, we can figure out the hypotenuse here. And what will be the hypotenuse? Root 2A. Okay, so in case if you don't know Pythagoras theorem, it is BD square will be equals to BC square plus CD square. Place your values of A here and simplify, you will get the value of BD as root 2A. So let's now find the magnitude EB, that will be equals to KQ upon separation, which is root 2A whole square. And that can be written here as KQ by 2A square. Now these are the values of EA, EB and EC. Correct? Once you figure out EA, EB, EC, let's find the resultant of EA and EC. We know EA, so let me remove this Pythagoras theorem here and let's write here EA in this direction and EC is in this direction. And what's the angle between them? 90 degrees. Sir, how do you know it is 90 degree? Because it's a square. So these are the vertically opposite angle. This is 90 and this is 90, right? So they are vertically opposite angles. Okay, great. So if these are 90 degree, what will be the resultant of two vectors having 90 degree between them? R will be equals to root under A square plus B square plus 2AB cos theta. Correct? And theta is 90 degrees. So cos 90 is 0. So we left with root under A square plus B square. Now if you look at the magnitude of EA and EC, where it is written here and here, both are equal. So if both A and B are equal, it will be root under A square plus A square, which is 2A square, or the resultant will be root 2A. Correct? So let's use this directly, and resultant of electric field, resultant R of EC and EB, resultant means the total effect of EC and EA will be root 2. You can write either EC or EA, both are same, KQ square by KQ by A square. Correct? So KQ by A square, this is the resultant. And where do we get the resultant? From 11th standard, I hope you know that it will be along this direction. By parallelogram law of vector addition, this will be the direction of R. Okay, inclined 45 degree with each. So we know that this R here, if you want to plot, it will be in this direction. So this is the resultant effect of EC and EA. And that is pointing along EB, right? So what will be the net effect of the whole thing? What is the net force at D? Sorry, electric field at D. So net electric field at D will be EC, EB plus the resultant of both the electric fields. So net electric field EB is how much? KQ by 2A square plus resultant is how much? It is root 2 KQ by A square. Correct? Let's take common out here. So KQ by A square taking common, this will give you half plus root 2. I hope this is clear. This is our second one. So ED is KQ by A square half plus our root 2. Clear it is?